Let us discuss about the potential difference between 2 points in an electric field. Say in the region of an electric field, say this is the region of an electric field in which there are 2 points A and B. We wish to find out the potential difference between point A and point B. Let us consider at point A potential is VA and at point B potential is VB. In this situation, if we place a charge Q at point A, then we can directly define that potential energy of this charge Q at point A is UA, we can define as QVA. Similarly, if the charge Q is placed at point B, then potential energy of Q at point B can be written as UB, which is QVB. And if the charge is considered to be shifted from point A to point B, we know as electric field is a conservative field. The work done does not depend on the path. But if it is transported from A to B, we can simply write that work done in shifting the charge from A to B is, this work done can be directly written as external work is always the difference of final energy and the initial energy, so it can be written as UB minus UA. If we substitute the values, it will be charge multiplied by VB minus VA. So always remember, whenever charge is shifted from one point to another in electric field, the work can be given as a product of a charge which is shifted and the potential difference between points. This is the way how we calculate the work. So here VB minus VA can be written as W by Q. So the potential difference between 2 points is the work done in shifting a unit positive charge from one point to another. This can also be defined as in an electric field, potential difference between 2 points is defined as work done in shifting a unit positive charge from one point to another. This is just a way to calculate the electric potential difference between the 2 points. If we can calculate the work done in shifting a charge Q, then we just divide the work done by the charge Q to get the work done in shifting a unit positive charge from one point to another. We can also calculate the electric potential difference between 2 points using the expression of electric field. Let's discuss the other method on the next sheet. Let's continue our discussion on calculation of potential difference by using electric field. So in the electric field, again we are having 2 points A and B, and say a charge Q is shifted from point A to B. Then as we have discussed, that work done does not depend on the path. But say in the path the charge Q is located at a point and it is experiencing an electric force F, which is given by QE, and it is displaced along the path by a distance dx. Then in this situation we can directly write work done by electric field in displacing charge Q by dx is this dw, and it can be written as simply F dot dx. This is the way how we calculate the work done. And in this situation, there is the work done by electric field because we have taken the force of electric field. And if we wish to calculate the external work done in displacing the charge, then dw external can be written as negative of this, so this will be minus F can be written as QE dot dx. This is the way how we calculate. And in this situation, total work done can be given as total work done in shifting Q from A to B is the external work done we can simply write as integration of dW external, which can be written as minus Q integration of E dot dx. That is from point A to point B. This is the total external work required. Here you can see the negative sign gives us the idea that this is external work done because Q is the force applied by electric field onto the charge. Now in this situation we know that potential difference between point A and B we can write as VB minus VA. This is given as total external work required divided by the charge. So we substitute the value. Here you can see that VB minus VA is given as minus integration of E dot dx from point A to B. Always remember that this is the expression which we can use for mathematical calculation of potential difference. And here you can also see that negative sign gives us an idea that in the direction of electric field if we are moving, then always in the situation we can say the potential is getting lower. So always keep this note in your mind that in the direction of electric field, always electric potential decreases. Let's have some applications based on the same. And this is the most important relation you should always keep in mind. In continuation, let's discuss the situation for uniform electric field. We know that in uniform electric field, field lines are always parallel to each other and equidistant from each other. Say we are having 2 points A and B located at a distance d from each other. Then as we have discussed in the direction of electric field, always electric potential decreases. So here we can directly write that potential at point B is less than potential at point A. And in this situation if we write VB minus VA is minus integration of E dot dx from point A to B, then we can see as the electric field is uniform, this magnitude of E will come out of the integration sign, and the 2 points are placed along the line in the direction of electric field. So E and dx are also parallel, so we can omit this dot product as it will result cos 0. So here we can directly write in magnitude. Here as A is at high potential, we can write VA minus VB is equals to E integration of dx from A to B will be D. So just keep it in your mind that the potential difference between 2 points along the line of electric field is the product of electric field and the separation between the two charges. Or sometimes we are required to find the electric field. E can be written as VA minus VB by D. This is also quite useful to be kept in your mind. And if we talk for non-uniform electric field, then we know in non-uniform electric field the direction of electric line of forces may change as well as their separation may also change. And say if there is a point A and there is another point B here, then we can see as B is in the direction of field, again the potential at B will be less than potential at A. Such analysis you can qualitatively analyze because we already studied in the direction of field potential decreases. So in this situation we can write VA minus VB. As I know that A is at high potential, I am taking VA minus VB is magnitude of integration of E dot dx from point A to B. Here I am taking magnitude irrespective of the sign of generation in the integration sign or the sign which was kept outside, because I know A is at high potential, B is at low potential, then VA minus VB will always result a positive value. So there is also a way mathematically you can evaluate the potential difference between 2 points.